method that we are going to use to find yp is called the method of undetermined coefficient. If we have the n order of differential equation, which is a non-homogeneous equation, that we have the term fx on the right side of the equation is not equal to 0. The answer of this differential equation gets to compose of two parts, which are yc, general solution, and yp, particular solution. Yc, you know how to find it from the previous lecture. With this lecture, we are going to find yp. And the first method that we are going to use is called the method of undetermined coefficient. With this method, we are going to consider the fx. Fx is going to be in the particular function as follows. Fx could be polynomial or the powers of x. In this form, x to the power k. K is just any number. K is just the positive number. It's integer, positive integer. Cannot be fraction, got to be integer. And the second function that fx could be is the exponential. Exponential is in the term of exponential of ax. A could be any number, plus, minus, pi. The third function that fx could be is sine, cosine, or sine. And the fourth function that fx could be is just the product of function 1 to 4. For example, x times exponential of x, or exponential of x times sine x, or x times exponential of x and times cos x, something like this. It's got to be products of the function from 1 to 3. Now from this, what if I have fx in the term of cos x? If I have fx as a cos x, can I use this method to find yp? No, we can't, because cos x is not 1 to 4. If I have fx in the function of ln x, can I use this method to find yp? Ln x, no. You got to find other methods, or tan x, tan 5x, or tan of any angle. But if I said that if my fx is equal to tan 45 degrees, tan 45 is equal to tan of the angle 45 equal to right? Tan of the angle 45 degrees equal to 1, right? So if tan 45 you can find, because it's equal to 1, you can put it as any function there. You can use it as x to the power k. K is equal to 0. Or you can use exponential of ax. A is equal to 0. But if you have tan 5x, you can't use this method to find yp. That's the whole point. Okay? If you have the number, the constant number, you just try to fit it with some type of the function right here, and then you can use this method. And again, this is just to remind you that if you want to use this technique to find yp, then fx is supposed to be just in this function only. If other function else, then you can use this method to find yp. And with this method, another things that you should know is just you got to know successive derivative of function x. What does it mean by that? The successive derivative I just give you an example. If you have fx is equal to x to the power 4, the set of successive derivatives of function x you can find by you do derivative of this function. Okay? Just do derivative of the function until it ends up. For example, for x to the power 4, you do the first derivative, you would get what? 4x to the power 3. The second derivative, you would get 12x to the power 2. The first derivative of this fx is equal to 4x to the power 3. Right? The second derivative of this fx is equal to 12x to the power 2. The third derivative of 24x, and the fourth derivative is 24. They're saying that when you want to write out the set of the successive derivative of the fx, which is equal to x to the power 4, you write the set, you know the sign of the set, right? The symbol of the set, which is the parenthesis like this. They're saying that you got to write the function of fx itself and its derivative without coefficient. So, we would get that the set of successive derivatives of x to the power 4 is x to the power 4, x to the power 3, x squared, x, and 1. That's called the successive derivatives, the set of the successive derivatives of fx. Sometimes I prefer the part that you see of this function. Let's see the other example. If we have fx is cos 3x, the set of the successive derivatives of cos 3x equal to what? The way that we are doing is just that we do derivative of cos 3x. We would get minus 3 sine 3x, right? And we do we do the second derivative of this function, we would get minus 9 cos 3x. But if you take a look at the function, it would be cos sine, cos sine, cos sine. So if it's repeated like this, just stop doing that. Just pick up the function. Now you have only two functions, which are cos 3x and sin 3x. So those two are the function in the set of successive derivatives of cos 3x. So I would say, I put the letter S as the set, okay, of the function. Inside here, you have only cos 3x and sin 3x. Now, what if we have function of exponential of 3x? Again, we just do derivative of this function. Successive, if we continue doing that until, if it is repeated, you just stop right there and just pick up the function that, is not with the function which is drawn from their derivative. Exponential of 3x. You do the first derivative, you would get 3 exponential of 3x. The second derivative, you got 9 exponential of 3x. So if you look at the function itself, have only 3x, exponential of 3x. In that case, you don't need to go further, just stop right there, okay? So the set of successive derivative of function exponential of 3x is just equal to exponential of 3x.